All right, here's an application of linear equations. So this is just something I thought you might find a little interesting. So alcohol is processed by the liver at a rate of 0.4 ounces every hour. So it's not exponential like other drugs. It's actually a linear function. So what this means is when alcohol is consumed, only 0.4 ounces of alcohol per hour is removed. It's not the same as the blood alcohol content that you see all those little measures. Those are affected by your sex, your body weight, your liver health, how much water you've drank, how much food's in your stomach. There's a lot of other stuff. So this is not valid as legal evidence or justification for consuming alcohol. It's just interesting. So suppose a person has just consumed 3 12-ounce beers with an average alcohol of 5%. So what we need to do first is find out what his initial amount is. Remember, the initial amount is your y-intercept. That's what we're trying to find. So at 0 hours, what is our initial amount? What's our B? That's what we're looking for. So 36 ounces times 0.05 would give us 1.8 ounces. So this person did 3 beers. He consumed 1.8 ounces. Now, the liver will process 0.4 ounces every hour. So after 1 hour, it will remove 0.4 ounces. So if you subtract 0.4 ounces, you get 1.4. And it will continue to remove until there's no more alcohol left. So 1.4 minus 0.4 would be 1 ounce, minus another 0.4 would be 0.6 ounces, and then minus another 0.4 would be 0.2. So after 4 hours, there's still 0.2 ounces of alcohol left in the system. So let's look at that graphically. Now, we only use this first quadrant here because this is a real-life situation. Our time cannot go negative, and our alcohol content cannot go negative. We cannot owe alcohol to our body. So at 0, it's 1.8. At 1, it would be 1.4. 2 is 1, so we can see that it's decreasing. We already knew that. It's decreasing by 0.4. And then 3 would be 0.6. There. See, it's making a nice linear equation because it has a constant rate of change. And then 0.2. So if we trace this back, it's the best line I can do. Right about there. So a little bit past 4 hours, somewhere between 4 and 5 hours, that amount of beer will be completely gone. Pretty interesting, right? All right, so we graphed our results. Next one. So now what we want is a linear equation for this, because you don't want to just make table after table. We want a linear equation. So when we make our linear equation, the first thing we need is our slope. And here, our slope was 0.4 ounces every hour. And if it says removed, we already knew that we would have a negative. So that is our slope. When they give us a constant rate of change, they're giving us the slope. So this is minus 0.4. So the next thing we need is our b. So if we write y equals mx plus b, we already know what the slope is. And if you look at our table, we also know what the y-intercept is. It's right there. It's 1.8. Now, when you do any of these problems, you really want to make sure that everything makes sense. So you want to define your variables. What does x represent? So it's our time in hours. Not hairs, hours. And our y, that's the amount of alcohol. So if you remember me talking about this before, the y is always what the thing is about. So this whole thing is about alcohol and removing alcohol. So all the things that involve alcohol are your y values. This is our change in y. These are our y's. It's the initial y, and so on. It's all y. X is our inputs. So in this case, it's time, because as time goes by, more alcohol is removed. So there is our equation. So if you replace these words now here, your equation should make complete sense. If it doesn't, then something's wrong. So y is the amount of alcohol. So it's saying the amount of alcohol is decreasing by 0.04, and this is why we put units. So the amount of alcohol is decreasing by 0.4 ounces per hour, and it's initially 1.8. We're starting at 1.8. That's right there, our y-intercept. So 1.8. This is always 0, 1.8. So this says 0 hours. 1.8 ounces. So that's why they're very important. The y-intercept tells us where we're starting. The slope is telling us how it's changing. It's going down. So this guy's saying it's decreasing by 0.4 ounces every hour. And now that you know these, you can plug anything in. So if we want to know how long it will take to get to a certain amount of alcohol, you plug in for the y. If you want to know how much alcohol is left after a certain amount of time, we plug a value in for x. So what will the BAL, the blood alcohol level, be after 1.5 hours? We already know x is the time in hours. So they're giving us, I'm giving you because I made this, x is 1.5 hours. It's time. So if we take our equation now, these are what they're good for, is finding stuff very quickly. And we multiply that out. So 0.4 times 1.5, what is that? So 0.4 times 1.5, that would be double, it's 0.6. So negative 0.6 plus 1.8. It's also half of the way. So if you think about it, it's decreased by 1.4 and then a half 0.4. So that's 0.6. If we add that to the 1.8, we get 1.2. So how much alcohol is left in the body after 1.5 hours? 1.2 ounces still. So our real question then is, how long will it take before the blood alcohol level is back to zero? So this person has no alcohol in their system. So we're saying here that our y value is 0. So if we take our equation again and plug it in and solve, and then divide, we get an x value of 416 is 4.5 hours. So 4.5 hours, that's how long it will take for this person to have no more alcohol in your system. And it's an average rate. Again, you can't use this legally, but 0.41 ounces is what I found online. I converted it to 0.4 ounces. So 3 beers, 1.8 ounces. If you find the alcohol, it's just a fun calculation. So there you go. Again, I am not saying drinking is bad for you. It's just, it's interesting because it's real life. So hope you enjoyed this. There's all the answers again. Thank you.